Hello, YouTubers. This is Divya Ams, and you're watching me on Divya Ams YouTube channel. So today I'm here to discuss you with the concept of array list and linked list. So you have heard of arrays and linked list, but haven't you heard of this collection framework? You heard of this collection framework in Java, but in Java generally, when we try to create an array and linked list, in array, if we try to create an array, we'll be writing the number of lines of code for asking the input from the user and again printing the arrays. And not even this, even we need to mention the size, like how much memory that array must be. So instead of all this hectic thing, in Java, we have come up with the concept of collection framework, where here the ArrayList is a class which is in the collection framework that will be dynamically allocating the memory, and the number of lines will be very less as compared to the general method of creating an array in Java. So let's dive into the collection framework topic. Collections are a framework in Java which are used for these ArrayList, linked list, creation of this ArrayList and linked list. So in collection framework, we have two types. One is collection interface and another is map interface. In collection interface, again, we have three types of interface. One is list interface, queue interface, and set interface. This array list and linked list comes under this list interface. So what is the difference between this array list and linked list? You might think that these both are same, but these are not actually same. Those are different since from the creation. So let's first understand the code of ArrayList and linked list. By understanding this code, you can actually get a practical experience with this, and conceptually also you'll be getting a good knowledge on this. So here I have two codes. One is ArrayList and linked list. Here, first I'll be showing the first code of ArrayList, and the second one is the linked list. So let's dive into the ArrayList code first. So ArrayList is a class which is actually in java.util package. So we are importing this java.util package. And then coming to the class, I've created a class demo4, and coming into the main method, here I have initialized n to 1 lakh. That means here we are actually allowing the ArrayList to store 1 lakh elements. That is great, right? So yeah, first I've initialized the n number, and then n variable, and then creating the array list. Here, I've created an object of array list A, and this is the array list class. And you might have seen some kind of difference in this, that is integer. Here, integer is nothing but a generic. Why do we need to specify this? To avoid a confusion for the new users, whether it's what data type it is. For suppose I have created a string data type, but the user might enter integer. That would be an error. We'll be getting an exception. So to avoid that, here we come with the generics concept to create this. Now, this is the syntax for creating the array list. Array list, a class type, the generic, the data type, and then the object of the array, and then referencing this object to this array list. Now, here we have performed three operations. First one is adding the elements to the array list. The second one is getting the elements, and the third one is removing the array elements from this array list. So for these three operations in this code, I've calculated the time so that we can understand in which operation does the array list is actually good at. So the first one is adding the elements to the array list. So here first, so in the first one, here, I have initialized this variable start time, and you might have seen this system.nanotime, which is used for calculating the time interval. I've created two variables, that is start time and end time, for the calculation of the time interval between the operation. So I have added the elements, I've created a for loop, and here This is the built-in method in the array list, which is used for adding the elements. A dot array. That means you'll be adding from 0, 1, 2, 3, 4 until 1 lakh. After that, again, since I've said you before, end time again. This is the end time. So this is the start time and this is the end time. That will be calculating by actually printing this. ArrayList add is equals to end time minus start time. That will be given the time interval taken for the array list to perform for adding the elements. And then this is first operation. Now the second operation is similar, same, but the method will be different, where you'll be seeing get I for accessing the elements. The same, I'll be printing end time minus start time, array list get, how much time it has taken for accessing the elements. And a third method is removing elements from the array list, which in where we'll be using this remove method, inbuilt method for removing the elements from the array list. And then printing. So these are the three operations that are performed. Let's see, like, actually I've run this before. Let's run it and see again. So here you can see the time it has taken for adding, getting, and removing. I can see that ArrayList has a very good, ArrayList is very good, pretty good at, accessing the elements at certain indexes. So not wasting more time, let's go into the second code, that is LinkedList. Now, coming to the LinkedList program, the same LinkedList is a class which is available in java.util package. I've imported this package. Now, coming into the class, I've created a class of demo file in the main method, same. Here also I've used n is equals to 1 lakh. And then this is syntax for LinkedList, where LinkedList is a class, and I mentioned this integer data type, and I've created object of LinkedList L. After that, the same. Here also I've performed three operations, that is adding, removing, and getting the array elements. Now the first operation, same. This is similar to the ArrayList program, L.add, and then I have calculated the time for these adding elements. And next one is accessing the elements. Even for this, L.getI, which is a predefined, built-in method for getting the elements. And then I've calculated this. Next, for removing the elements from the linked list. So here you can see that for removing elements, I have used remove I, that means remove I, remove that particular element. Here I have performed for all the elements that must be removed. You have performed the remove method to remove all the elements. So how much time it would take for a linked list for that. And then I've printed linked list remove, that is end time minus start time. Now let's run this code and see how much time it is taken for linked list. Oh, sorry. You have run the previous code. Let's run this code. Run demo file. So yeah, now you can see the output, linked list add, get, remove. So based on this, I can say that linked list is pretty good at removing the elements. So let me just show you the difference between ArrayList and linked list by combining these two codes into one code. So here I'll be just cutting the code and then I'll be pasting over here. So you can see the difference between ArrayList and linked list at a time. It's the error. Let's run it so that you can get. Okay. Yeah. If I've made a mistake, I've initialized it again. Let's remove it. So yeah, let's run. As you can see, still it's running. Yeah. So we got the final output, ArrayList and linked list. So you can see for first ArrayList is good at getting the array elements. Okay. Next one is linker list. So in linker list, you can see linker list is good at removing the elements. But when you compare this array list and linker list, you can see that array list is actually good at getting the elements, and linked list is actually good at removing. Why array list is good at getting the elements? Because in array list we don't traverse from one element to other element directly through indexes. We can actually access that element, but for linked list here, that's not a matter of what we have seen in array list. So in linked list we'll be having pointers, 2 pointers. So one pointer for the previous one, and another pointer for the next one. So here the traversing will be done for each node. Even if you want to access an element in linked list, that pointer must be traversed from one node to another node. That will be taking quite, hard time, very, very difficult time for that. So it's better to use linked list for getting the array, getting the elements. And for removing, if you see comparability, for removing, linked list have, great efficiency than array list. Why? Because linked list here, that's a very small matter. You need to remove the element of that particular node and then update the pointer, which is quite great. But in array list, it will be taking a lot of time for removing the elements. And for adding, as you can see again, I think ArrayList has taken less time than linked list. It's because of adding is quite easier in ArrayList than linked list. Yeah. So this is the code for these ArrayList and linked list. I hope you have got pretty much good in these two concepts. See, these ArrayList and linked list comes under the collection framework, and you can use it dynamically. That means the memory is allocated dynamically. Thank you for watching this video, and please do like, share, and subscribe to my Divya Am's YouTube channel. Thank you.